first requirement is to find the value of a plus b plus c plus d. This is given tangent a equals to 1 over 2. On the diagram, it means that the opposite is 1 and adjacent is 2. So this is angle A. Likewise, this is angle B, this is angle C, and this is angle D. To find the sum of all angles A plus B plus C plus B is the same as finding argument 2 plus I, argument 7 plus I, argument 8 plus I, and argument 18 plus I. Okay, as you can see, this is one of the properties of the argument. Argument z1 plus z2 actually equates to argument z1 times z2. So simplifying it, you will get a case of argument 2 plus I times 7 plus I times 8 plus I times 18 plus I. Simplifying it, you will get an argument of 1625 plus 1625i. So using tangent inverse 1, your answer will be pi over 4. This is the second requirement to find the value of modulus 3z plus 2w mod. Okay, before you start this question, you have to first accept this equation that modulus root z is actually the same as root modulus z. It doesn't matter if the modulus sign is outside or inside, you are going to get the same value. To prove my point, let's let z equate to 3 plus 4i. Okay, when the modulus sign is outside, your answer is 2.236. You get the same answer when the modulus is inside, 2.236. Therefore, this equation has to be correct. Okay, since this is a property, z times z conjugate equals to modulus z squared. And given this equation that mod z equals to 2, if you were to square the left hand side, you have to square the right hand side. So you create a mod z squared equals to 4 equals to z times z conjugate. Isolating the conjugate, we get 4 over z. Call this equation 1. Do the same thing to modulus w equals to 3 and you get w conjugate equals to 9 over w. Call this equation 2. Okay, since z cap equals to 3z minus 2w, z times z conjugate would equate to 3z minus 2w squared. Using substitution, z equates to 3z minus 2w, and this becomes 3z minus 2w conjugate. It is wrong to think that the conjugate of 3z minus 2w is simply 3z plus 2w. This is incorrect. Okay, so on the right hand side, we know that a 3z minus 2w modulus is root 6 times root 3 is a given. Therefore, if you were to square the whole thing, you're going to get a 108. Okay, the way to simplify this is to multiply the conjugate into the z and into the w. So you get a 3z minus 2w times 3z conjugate minus 2w conjugate. This is the property. Whenever you have two complex numbers inside a bracket, z1 plus z2 conjugate, the conjugate is allowed to multiply inwards into here and to get a z1 conjugate and a z2 conjugate. Since you have already found earlier what z conjugate and what w conjugate are, sub it into here and sub it into here to get a 3 times 4 over z and a 2 times 9 over w. Simplifying the equation, you should end up with a minus 36zw minus 54z squared minus 24w squared equals to 0. And that would be the same as 9z squared plus 6zw plus 4w squared equals to 0. Okay, by completing the square, I know that my equation can be reduced to 3z plus 2w squared equals to 6zw. Okay, when I throw over the square, it becomes a square root. Taking a modulus on the left hand side, I have to balance up by taking the mod on the right hand side too. So right now what I really need is to solve for this. Using this formula as earlier explained, I'm going to simplify my right hand side. So the modulus sign is being thrown in to become a mod root z mod root w times a root 6. So the answer is 6.